right, this is a lesson on section 10.2, graphing any quadratic equation in the form of ax squared plus bx plus c. What we have to know is that the x-coordinate of the vertex is negative b over 2a. To find the y-coordinate of the vertex, you plug that x value back into the equation provided. So a couple things here. To remind ourselves of the vertex, if I have a parabola that is a U-shaped graph, this vertex is the lowest point on the curve. And also, if the parabola opens down, this vertex would be considered the highest point on the curve. So this is clearly an important point you have to find, and the way we're going to do that is negative b over 2a. Now you're going to want to memorize this, and let's give you some help. There is a formula called the quadratic formula. We learned a song about it. I'm not going to sing it right now, but it's negative b plus or minus the square root of b squared minus 4ac, and we're going to divide it all by 2a. Now, if I take away the discriminant part, look what I have left over. I have the formula for the x-coordinate of the vertex, negative b over 2a. All right, we're going to do 3 examples here to help us make meaning of this. The first example is right here. So I have a quadratic function in the form ax squared plus bx plus c. Let's first note that a is equal to 1 and c is equal to negative 5. Now, the other day we learned what these values do to the graph. With an a value of 1, we're going to have normal width, and we're going to have a graph that opens up. We learned yesterday that c is a vertical shift, but it also is an indicator for the y-intercept. The y-intercept is going to be 0, negative 5. So the new content we're putting in with this lesson is the middle portion, the x-coordinate and the y-coordinate of the vertex. The x-coordinate of the vertex is negative b over 2a, which in this case, b is equal to 4, so that's the opposite of 4, times 2 times a, which is 1. Negative 4 divided by 2 is negative 2. So I'm ready to say that the vertex is located at the ordered pair negative 2, comma, whatever that y value is. We will find that by plugging the negative 2 back into the vertex, or back into the equation. So let's see, negative 2 squared plus 4 times negative 2 minus 5. Negative 2 squared is 4, minus 8, minus 5, and what we get here is I think, negative 9. So the vertex then is at negative 2, negative 9. I'm going to go ahead and locate that on my graph. All right, so we're going to graph negative 2, negative 9, which is located here. I'm going to put a V to stand for the vertex. Now with the other indicators here, we should be able to graph this parabola. The y-intercept is at 0, negative 5. So that's located at 1, 2, 3, 4, negative 5 on the y-axis. And with the parabola, you're going to want 3 points. The other final point we will locate through the axis of symmetry. The axis of symmetry is the vertical line that goes through the vertex. And what we're going to do here is recognize what it tells us. It tells us that if we have a distance of 2, we should be able to go to the left of the axis of symmetry and find another point. So with these 3 points, we have a parabola that opens up. It has normal width, and it has a y-intercept of negative 5. All right, here's another example. Let's see. Note here that the a value is negative 2, the c value is 0, and those things tell us many things about the graph. This graph is going to open down, and it's going to be a little bit more narrow than the typical x squared. We know that the y-intercept is going to be found at the point 0, 0, so that is the origin. So those are the easy things they give us. The more difficult thing to find is the vertex. So what we're going to do is we're going to do negative b over 2a, which is the opposite of 8, over 2 times negative 2. So be careful here. Let's see, this is going to be negative 8 divided by negative 4, which is positive 2. So I'm ready to say now that the vertex is located at 2 comma something. That something is found by plugging that 2 back into the equation. So y is negative 2 times 2 squared plus 8 times 2. All right, order of operations says we got to square first. So that's negative 2 times 4 plus 16. And then I'm going to get negative 8 plus 16, which is 8. So that's the vertex, 2 comma 8. That's going to be the highest point on the curve because it does open down. Let's see, 2, 8 is right here. There's a y-intercept at 0, 0. And that third point is going to be found. Let's also label the vertex. That third point is found through the axis of symmetry. I know to be symmetric, it has to have the same distance on either side of this green line. So at this point, I have to have another point at 4, 0. So we have a parabola that opens down. Its vertex is located at 2, 8, and it has a y-intercept of 0, and it's a little bit more narrow than normal. All right, for the last example, I have, let's see, a is equal to 1/2, c is equal to 3, and these two numbers tell us many things. This is going to be a little bit wider than normal. We know that this is going to open up because it's a positive a. The c value tells us the y-intercept. The y-intercept is going to be at 0, 3. And so those are the things that they just hand to us. We've got to do some work to gather the x-coordinate and the y-coordinate of the vertex. All right, so negative b over 2a is the x-coordinate. That's the opposite of negative 2. There's your b. The opposite of negative 2 over 2 times 1/2. So let's simplify the top and bottom. The opposite of negative 2 is positive 2, and then 1/2 of 2 is 1. So right now I know the vertex is located at 2 comma something. Let's find that y-coordinate by plugging it back into the equation. That's 1/2 times 2 squared minus 2 times 2 plus 3. Order of operations, we must square the 2 first. So that's 1/2 times 4 minus 4 plus 3. And this simplifies into 2 minus 4 plus 3. Let's see, that's going to be 1. So the vertex here is at 2, 1. Let's label it with a b. The y-intercept is at 0, 3, which is located on the y-axis. And let's find that axis of symmetry located through the vertex, that's vertical. And this axis of symmetry tells us a point across from that line, which is going to be at 4, 3. And then graphing this, I get a parabola that opens up. The vertex is located at 2, 1. It's a little bit wider than normal, and it opens, and the y-intercept is positive 3.